So this is about people asking questions mainly. So I've got lots of slides on topics, and I'll go through. My disclaimer is I'm a web designer here. My experience is mainly in design and web design. So I'm not a computer scientist, so most of the topics will be quite high level. But I'm hoping they're going to be useful because I'm trying to put it in a way that people can understand. When people talk about this stuff, you can have a basic kind of underpinning of what that actually means in your mind, hopefully visually. So I'm not a computer scientist, but I am a web designer. I have been for about 7 years. So if you have a problem with what I'm saying, or you know better than me, or you have some experience in one of the topics, just let me know and put out your experience and ask me questions and stuff. And thanks for everyone who gave me questions originally. So what is the internet? Anyone?
Cats.
Cats. That's on the internet, right? So this is quite a stupid question, but it's quite an interesting one because lots of people think of it in a very abstract way. And what you can think of it in terms of is basically three discrete elements. So the internet. Hi, come in. The internet is basically cables, real physical stuff. Like they drag these cables across continents, through the ocean, to connect up countries. And the more massive fibre optic cables that go to your country, literally the faster it is to get access to different servers in different parts of the world. When we first started using the internet, a lot of the internet traffic was going through the US, regardless of what those servers were, because they just had the piping. They literally had the pipes to send that information. So along certain shorelines, I think there's one in Dorset, something, connecting us to the continent. But you'll see these silos, and there's literally like a big station where they plug these things in and they submerge them and put sand over them. So if you found out where all these were and cut them up, there would be no internet. So there you go. That's going to be my theme of today, basically, dispelling the internet as a thing you can't mess up, because you can. This is one of my favourite examples of server room. This is like the WikiLeaks, basically like Batman evil dungeon. And they've got this weird meeting room and a couple of computers and then a stack of servers underneath. So the second main aspect of the internet is obviously computers. So the things that these pipes are connecting to. Check out more photos of that, because most server rooms are really dull, but that one's pretty cool. And then the third aspect is obviously what is it you're actually transporting across the wires and how are they communicating. So what Tim Berners-Lee did is he had all this infrastructure in place. They had these different universities connected up, and they had CERN and DARPA and things, and they were communicating already. And Tim Berners-Lee worked with a team to formalize how that data was transferred, and he did that by making HTTP, which is a way of formatting the information you're sending, so that anyone who gets it knows that in between knows to where to send it and what information is there. And obviously the markup language, which happens to be HTML. If Tim Berners-Lee didn't exist, I think the internet would still exist, but it might not look like that. It might look like something else. It might be 3D. I don't know.
Was he the guy who was in the Olympic?
Yeah. And he's like the father of the internet. But actually, it wasn't. He was a part of a larger puzzle. For a lot of it was CERN and DARPA in the US. So this is a really bad picture, but I didn't really have time to draw out everything. So the basics, and do stop me if it's getting really boring or anything like that. But the basic scenario is you put in a URL to your computer, and that sends it to a local ISP, which is like Virgin Media or BT, whatever, and that request gets through this network of computers, which basically don't look at the information, just send it to the next place. So your pipes are connecting computers to computers to computers to computers all around the world until you find the right one. And then they do that through DNS, domain name servers, and they are the servers which are basically the crux of the internet. And everyone says the internet is a distributed network which can never be taken down. That is false, because these servers all around the world, and they're looked after by mainly governments and big corporations with governments involved, they tell you where the information is. So when you register a domain, you're basically paying for someone to keep a little log of the connection between a computer and that name. So benbyford.com redirects to an IP of a computer somewhere, and that's kept on these domain servers all around the world. And it finds it and goes, okay, you're talking about this information on this computer, gets it and sends it all the way back through that network.
So if you're looking for something on Wikipedia,
yeah,
you're going to request some information or a location from the domain name server.
Yeah.
And then it's going to route through to wherever the Wikipedia information is held, and then it's going to send it back to you.
Mm-hmm.
Is all the Wikipedia in one place? Or
no, I mean, so if you're clever, like, we're having that problem where our internet here was distributed through pool or something. That's the sort of weird stuff that you can do. So we house most of our images for Virgin.com we used to, on Amazon servers. And we did that because they had those servers all around the world, and they basically just copied that information to each one. So you had a local version within that country a lot of the time. So that's why you use those services, because it's much faster to get things from within your country than it is going across the world and getting it. So it's about speed of access. And also it costs money just to send information, and there's a lot of like carbon footprint stuff with every time you Google something, you're actually making a request to a server, and that takes electricity and the infrastructure to make that happen. So I think there's a lot of information you can look up about how much a Google search actually costs, so you should check that if you like. So has anyone got any more questions about that?
When you said computers, do you mean computers that we would recognise, or
yeah.
rooms full of sort of lots of electronics?
Yeah, did you see the picture of WikiLeaks earlier?
Okay.
Yeah. So, I mean, like your desktop computer, but on the side in a rack. And I think most of the Google stuff now, you can't actually get inside the centre because it's there's lower the environment within the server rooms isn't fit for human life, so that the computers work faster. So they have robots now that actually unplug and plug in new computers. So actually it's a massive deal to get into those places because they have to basically shut the whole place down, or sections of it. But you could host your own website on your own computer. There's no reason why you can't. The only annoying thing is that if you turn your computer off, the website doesn't exist anymore. So no one can access it. So when I'm developing a website, I usually work on it on my computer locally. And if I want to give people access, I can. And then I put that online somewhere and make it publicly available. And it sits on a server where you're paying someone to basically have it up 99.999% of the time. So that's what that is about. So when I was saying about taking down the internet, right? This is how you do that. So there was a really interesting case a couple of years ago where someone worked out that there was a problem with how people can access these, and he went in and proved that by changing one of the logs on the DNS server, so that, say we changed Virgin.com to Virgin.xxx, whatever, that you're redirecting all the traffic that's ever going to go to that website to a different place. So if you wanted to take down the internet, you would go to these DNS servers and wipe the information, or corrupt it in some way so that when you're requesting a domain name URL, it's not going anywhere because it doesn't know where it is. And you know when you type in something wrong, it goes not found, whatever. That's what would happen. And that's how hackers like to take over your PIN codes and stuff. They redirect you from what looks like the place you're supposed to end up, and it's actually on a different computer, and it's taking your information. So that's bad, I suppose. And lots of activists are doing fun things in that world where you can get tiny computers which you plug into the wall in cafes and stuff. And if you have like open access Wi-Fi or something, you can piggyback off that Wi-Fi. And if you connect to that computer instead of the Wi-Fi, it can provide you with different information instead of the internet. So these activists in Sweden were changing the news. So if you went into the cafe and logged onto The Guardian, it would have the day's news, but it would have it written by them. So they would kind of interpret the news as it was, rewrite it, and upload it so that people thought that men, taking over the world and women were fascists or something. I don't know, like it was more of a kind of power struggle between them and the government than anywhere else. But you could see how easily someone could do that and take your information and take your data, your credit cards, anything you basically type into the internet. So it's actually infuriatingly easy. So do be careful out there. So this is a lot of the fundamental boring stuff. So I'm going to try and run through it. I've made it pink, so it's more bold. But I had a really good question about what is coding, and that's like an endless question, and we could have this whole hour talking about it, but we won't. But if you want to talk to me afterwards, then you can. So when people usually talk about coding, they're usually talking about websites, right? But coding fundamentally isn't necessarily about websites, and a lot of the time websites aren't coding, and I will tell you why. There you go, Will I Am. Great coders are today's rock stars. So they're having a big push in the US at the moment to get lots of coding in schools, and we've started that in the UK a little bit with Coding Club. Arguably the first programmer was Ada Lovelace. Has anyone ever heard of Ada Lovelace? She is the daughter of Lord Byron, who I'm imagining you've heard of, and she was told by her mother that she couldn't do English or poetry in schools because she basically hated her husband and his poetry and everything he stood for, so she did a lot of mathematics. And in the Science Museum they have this replica of basically the first computational computer, which is a massive thing with loads of cogs and stuff, and if you could go over there and see it, it's just a load of wheels and cogs, but it grew out of the spinning jenny and being able to put punch cards into making fabrics and things like that. So what Ada did was the first kind of mathematical computation through punch cards on a system where you could give it information. So she'd put all these cards through, and then it was set up, and you'd go, okay, I want to know the square of 14, and you put in 14, and you put in square or something, and you crank all the things through, and it'll give you an answer. And you could put in anything you like, basically, and that was the idea, that you could compute stuff. And that was the kind of the first time that we had a computer which didn't do a specific thing. So Ada Lovelace, first programmer and female. So this is kind of like a allotted history of different coding languages. I'm not expecting anyone to know anything about this. In 1951, the assembly language was created. So if you were a programmer, you could go down to your local town hall with a big thing of clipped-in cards, and you run it through a big machine, and you get an answer out the other end, and that's how you program. And that was basically ones and zeros. 57, Fortran came out, and instead of programming with ones and zeros, we were talking about abstract concepts like algebra, basically. So you have A, and A equals 17, and that goes through, and A is changeable, and updates, things like that. And it was using more natural language, so you could say, if this, then do this, instead of 1 0 1 0. So that was like a big leap forward. Did anyone have a BBC Micro or anything like that at school? Or you were probably programming on BASIC then, and having a little command prompt and asking it to print stuff out.
What were programmers doing before 1951? I mean, if you were super smart, you had the skills that nowadays means you would be a programmer.
Yeah. What
were you doing?
You were probably a scientist.
Okay.
I mean, before that, it was basically winning the war, right? It was basically like, this all grew out of the war, basically, you know, because there was so much like development in science to outsmart the Germans or the Americans, whatever it was, that they made ciphers and they had to decrypt these ciphers, and the best way to do that was to create these computational ways of doing it. So if you put in the message, crank it through, it would give you the message out the other side instead of having to sit down there with a pen for hours and then you would be bombed, basically. It's quite simplistic, but but you know, a large part of the war effort was finding out how to decrypt everyone's messages, and that was Turing and people like that. So there's that. There's more stuff that happened, which is exciting. 1972, they started creating C, and that kind of underpins all computers that we know now, which is good to know. SQL, if you're familiar with Excel, Access, something like that, you might know a little bit of SQL. That's basically like, there's information, let's look up where things are with loads of data. So you can go, from this table, I want all the things that match this. And that's what SQL is. Java. So this is like the stuff that you kind of get into nowadays. So PHP, Java, JavaScript, Lura's fancy language, which I just started learning. But it's the stuff that is more associated with web stuff. So it's there to interact with web browsers rather than computers specifically. Although Java and PHP you can make applications with. And Google and Facebook keep making stupid new languages. Dart and Clojure and Go and Scala, Groovy, F#. They're all really, really recent languages which no one really uses yet because it's only internally at Facebook that they use Groovy, for instance, which is just an iteration on PHP. But if these things aren't free, open source, then they don't have the uptake because people have to pay a license fee or whatever, which is why Windows is dying.
Windows dying, sorry?
Sorry, that's just a brief stab at Windows licensing and proprietary systems. Rather than downloading a Linux system or something like that, and it's completely free and it updates and people are constantly working on it instead of just one corporation. So yeah, I'm going to try and get through this as quick as possible so that people don't have to listen to me talk about coding. But interpreted versus compiled languages. So there's a fundamental difference in coding languages where one is interpreted, and some examples of that. So you can write these programs on any computer and it will run on any computer, and you can just click go and it will do it. This differs from compiled languages like C, Pascal, BASIC, which are specific to that computer. So you have to compile them. So when you click go, the computer goes, I'm making a program for you, and it doesn't actually run the program, it just makes you a package which is actually binary code. So the difference is that this runs tons faster because it runs exactly on your architecture of your computer, whereas this runs with the help of other things which have to interpret what you mean by that on this system. So if you're running a Mac, for instance, and you wanted to run a program which is a Windows program, you would have some difficulty because you'd have to get a load of layers of programs to interpret the specific code for a PC system, basically. So interpret is tons easy to work with, and it's much faster to develop, but compiled languages just run faster. So on your iPhone, they've got an iteration called Object-C, and that's a compiled language. You make an application, and it only runs on your iPhone. It won't run anywhere else, because it's all the ones and zeros are only specific to that hardware. So, something to bear in mind when you're talking about stuff with people, I suppose. Okay, so this is a bit more exciting. If you have any questions on this, I've only just put together a couple of ideas. So, if you're going to make a website yourself and code it, you'd want to learn these things. So, HTML, CSS, JavaScript, and either one of these languages. And you could just get away with just doing that, but it wouldn't be dynamic, so you couldn't have a back end and update it and stuff. And that's basically what those application languages do. So when you're talking to people about having, like we were talking to James the other day about learning coding or something, he wasn't learning coding, he was learning HTML, which is one aspect of making a website, but it's, as I'll talk to you in a second. Actually, sorry, totally missed that one. I had a nice slide on HTML. There you go. Yeah, so I talk about all these languages, but everyone knows what HTML is, right? Is it? And it's not a coding language. It's a makeup language. Does anyone know what a makeup language is? It's nothing, basically. So in Word or something, and you make something bold, and you put a paragraph in, and you make it a header or something like that. If you imagine that you can see that there's a header there, that's what HTML is. It's telling some other system what to do with it. So it doesn't inherently do anything itself. It's just text, and it has no logic. So the prerequisite for any coding languages is it has logic. So you can tell it, if A is this, then do B. Or for all these things, do this to them. Or all these sorts of things. So it has inherent ifs or mathematical computation, that sort of thing. HTML has nothing. It's just how you interpret a document. You could put it into Word, you could put it into wherever else. Just so happens that web browsers have this way of showing the information.
So just for the structure of how text is there?
Yeah, it's just laying out text.
Stuff's position.
Yeah, or images or whatever. And the more as time progresses, we get more things added to HTML, but it's just so that browsers can interpret it. And annoyingly, not all browsers interpret it the same way. So that's why you have to test in lots of different places, because they might display your image like this in one browser, and it might be displayed like this automatically on a different browser, which is a headache for me. So this is kind of what that looks like. So you can see that there's a section here, and everything within that section is some text. There's a heading, there's a paragraph. I made this small. This is the beginning of the presentation. There's a link here with a reference to this page on the internet, and presentation, and there's more text. And then I'm closing off all these things, so it's all contained in blocks. But inherently, it doesn't actually do anything. It's not computating any math or anything like that. As opposed to something like JavaScript, where you can obviously see that there's a var is for variable, and I'm assigning a number, and then I'm squaring it. So I'm running it through this small function where I'm going to take A, bring it into this function, and return A times A, which is the square of A. And then if this happens to be bigger than B, I'm going to print out this. So if A is smaller than B, then we won't print that out, and that's the inherent logic in the system. Does everyone understand? Yeah? Cool. Okay, so build yourself with code. So this is not massively attractive, but there is Code Academy, Treehouse, lots of places online where you can learn to code. There's General Assembly. So if you want to make yourself a website for your own personal use or a company or something like that, you can go and you can, in quite a short amount of time, you can work out how to make something that looks okay. And HTML is really easy because, like I say, it's just knowing what you want and then going, oh, I need a paragraph there, so what is a paragraph tag? Or I need a heading, what's a heading tag? And once you know that stuff, it's just really easy. If you don't want to code, there are lots and lots of things, like WordPress or Wix, which is a new one, Tumblr for blogs, Moonfruit, which is more for artists and stuff, or Squarespace, you can run a shop from that, with Shopify. Loads of things like that, which just have text inputs and move things around and that sort of thing.
This was the question that I asked, so
Yeah.
just to dwell on it for a bit. Specifically, my question was if you want to build a different type of website, so if it's just going to be information services, maybe you want to manage information that people are submitting, or maybe you want an e-commerce element to it. They're all very, very different, and they're going to hook into lots of different systems that are beyond your own website. So specifically, what websites or what services do you need to know about or subscribe to or access? Do you know what to build all that? Because Shopify is all about that billing platform to be able to sell product.
Yeah.
So what is like Squarespace and Moonfruit and what?
Well, I would urge you to check them out and to see what they provide, because some of them will provide more or less what you need. Like Squarespace would be a website and you can plug in an e-commerce element to it. And you can theme it how you like, and you can pay for a more fancy theme or whatever like that. Whereas WordPress is a little bit less like that, and it's more just kind of a blogging platform or just a singular. This is information about my business or whatever. If you want to talk to me more specifically afterwards, but we're going to get onto API stuff later. So websites do need to connect up inherently in a network, because that's how the internet works, connecting all different things together. Does that help at all? I mean,
yeah, well, I guess there's like.
Yeah, I mean, it's the more you know, the better informed you can make these decisions and what things you should and shouldn't do. For example, when we were building Virgin.com, they were like, we're going to use Drupal as our CMS system, and we're going to use Elasticsearch, and we're going to use all this other stuff. And we were just like, that's great, but how is this all going to fit together, and is it all going to work together, and if one thing goes down, does it affect us, and all this sort of stuff, because they are literally on different virtual computers. So it's definitely something you have to consider when you're working on a larger project. If you're working on a small project with just one website, you're better off just using other people's services, I would say. Because everything is less likely to go wrong, because it's a proven system, like WordPress, for example. Everything costs. So a lot of the time when I was a freelancer before, people either had no idea what things cost, or they were interested in underpaying or going for something else because they thought it was better value for money. You're basically going to pay regardless of all these things. All these things, everything on the web costs. You have to buy a domain name if you want a domain. If you want to use Squarespace, you have to pay a subscription. If you want to use Wix or Moonfruit, they put ads on. You're always paying somehow. WordPress is a bit more of an anomaly because you don't specifically have to pay, but you just have to deal with their system, and it's really clunky and horrible. So you usually have to pay a web designer to sort it out anyway. So,
and how much does that cost?
I'm charging £35 an hour, but I'm not charging for any meetings or anything like that. So
there are, there's like so many people working on this, but for someone who's never built a website before or has really thought about this, you don't really know where to look.
Yeah.
There are definitely places where you can go to, say, India, and there's just like...
Yeah.
Right?
The thing, I had a hard line with that sort of thing when I was freelancing before, where if I can't go and shout at them, I don't want to work with them, because I literally don't have any idea of the competencies of these people anywhere else. I don't even like to work with people in Leeds if I can't guarantee that their work's going to be good. Not specifically Leeds, but like somewhere else. I literally like to be able to phone people up or go and see them. I keep hearing horror stories about big teams in Egypt or India or anywhere in the Eastern Bloc, of them doing great work, but it being completely like the wrong thing or not work for their system, other systems or whatever. So you're basically, if you want to do anything like that, you want to have a consultant in the UK who can vouch for them or work directly with them, basically. It's a very dicey way to go.
And where would you go to educate yourself about various different sources of developers that you can call from?
I think just get yourself educated. Go to. No one's good at the internet because it's such a massive thing, right? So you could be a great PHP developer but know nothing about Ruby or JavaScript. So you basically want to scratch around for and talk to people who know what kind of things are possible, and then you want to look at those things and see how up to date they are. So a really good way of dealing with it is if someone's using an open source bit of software, you literally go and look at the open source page and see how many people comment on it, how frequently is the forum used, how many people are on the forum, because that'll give you an indication on how well updated it is, and that then reflects on security of the whole system. The more people using it, the more likely to come through pitfalls, which they will then plug, basically. So I used to use a CMS called Frog CMS, and it basically died a death because everyone went to do other stuff. And you can still use it, but you wouldn't, because it's out of date by 3 years. So you want to make sure that you're using something up to date. Maybe you know a lot of Ruby developers, so you might want to use Ruby because you know that you have access to those people. You just want to put yourself in a position where if one person from the team leaves, you can just fill that gap with someone. They're not using something exotic that no one knows about. You wouldn't use like Go or Dart or F#, which only go Google, because you just get charged for the knowns for it. So there's lots of considerations, basically, but just talk to people who have a kind of general overview understanding on development and design, because most developers don't know shit about design.
Yeah, sure. I mean, I've done courses in General Assembly, but it's just more like, was there a place where clearly you go here if you want to get a coder to run your website or not?
You can hang out.
Yeah.
Yeah, you can hang out in Shoreditch. I mean, that's it really. go to some events run by the Three Beards, and you'll be sorted.
It's word of mouth, though, isn't it?
Yeah, but you also want someone else to vouch for them. Yeah, that's it, basically. Everything costs. Don't be ripped off though. Hopefully. So get someone to vouch for the person's work, and also get lots of quotes. And don't go for the lowest quote as well, because they are generally just trying to, get your work when they're not necessarily the best person for the job. They might be, but generally they won't be. People who care about their work generally pay themselves what they think is the right amount.
Are they the tech equivalent of the first rail franchise then?
Yeah? Okay. What should you ask this web designer? What CMS are you using? Is it going to be bespoke? If it is, don't use it. Is the rule of thumb. Unless you want a relationship with this person or company for 3 years, don't get bespoke CMS. If you're happy to have that relationship, then it could be more fruitful because you can literally build whatever you want. But it takes longer, it's more costly, and it's a relationship that you really have to keep up. Whereas open source CMSs like WordPress, Drupal, Joomla, anything like that, there's thousands of people who work on websites like that every day. So you can content management systems, yeah. I've got an acronym thing in a second, and I've got that one on there, so you'll know that one, unfortunately, already. What languages are they using? So, like I say, don't use any exotic languages because you have to pay people loads of money if that person leaves. How much is hosting? Shop around for how much hosting costs because they usually rip you off. I've got a good friend of mine who rips people off all the time with hosting because it's really bad. But this is like 70 quid a year, and it's like it's not 70 quid really, is it? It's like no, but it's my time as well, which is kind of fair enough. But you want to look between, for a website which is going to get 10 to 1,000 people a month, you're looking at about 30 to 50 quid. If it doesn't, we pay thousands a month. I think it's something like 7,000. Also, it's something ridiculous like that. But that's because we have these different systems running at the same time, and we have 3 million people accessing it every month. So we're paying for kind of the stability, security, and all these different systems. So yeah, don't pay any more than that though, basically. And yeah, like Amazon and loads of other people offer really cheap entry-level stuff. So you can make a website, you can whack it up somewhere on S3 or there's other places like Heroku, stuff like that. And I'll get onto SaaS in a minute, but they are, instead of hosting a website on a server, they have effectively a big server and then lots of little pots for people. So it costs hardly anything, but it's not as stable as having your own kit, and that just costs more. So my website for my business is running on Heroku at the moment, and it's costing me nothing. It doesn't actually cost me anything at the moment because we have 100 users or something. As soon as it ramps up, we have to start paying for more and more bandwidth, and then it gets quite costly quite quickly. So when that starts happening, we'll move it somewhere else and stuff, because it's worth moving it, because it's quite a time-consuming thing to do. But like I say, if it doesn't ramp up, then it's cheap, nothing. What is responsive web design? Anyone?
Is that where it looks different depending on the size of the screen?
Yeah.
So rather than having images down the side, it kind of stacks them on top of each other.
Yeah. So loads of websites still do it, but you go on your phone and you look up a website or a tablet or whatever, and it's massive, and you have to zoom in and out, and it's not friendly to click on anything. All the links are really small, and responsive web design is basically no matter what size screen you have, let's try and make an experience for that screen. Using the same content, and that's different to what we were doing about 4 or 5 years ago, where it was 2 different experiences instead. So you had a whole other website, which was a mobile website, which is a massive ball ache because you had to make 2 websites firstly, and it cost more, but also you had to somehow duplicate the content between them, or aggregate the content between them, and decide what should go in the mobile one and what shouldn't. Whereas this way, with responsive web design, you're just saying, I don't care where we are, I just want it to look nice. And that impacts lots of other things, like if you have big images, it's going to take longer to download on your phone, so you have to take account for those things. But that's the basic
Is it one
aspect
of
of it.
3 basic web languages that does that, or is it something else?
The responsive web design is it's a way of thinking about doing your web design. It's not actually anything in itself.
Right.
So
just the way you structure
yeah.
the HTML
Yeah.
code.
It's just the way you structure it. And if you're doing mobile first, you're thinking about the mobile experience as you're designing before anything else. So you literally make it look good on the mobile, and then you get bigger and bigger screens and make it look good on desktop.
I know some mobile first apps. But
Mhm.
what's an example of a mobile first website?
Version.com.
Okay.
Yeah. I mean, we had, before we got it redesigned, I actually did some responsive web design stuff on just the article pages, so it at least worked on your phone and you didn't have to zoom in and out and stuff. But the new website is basically, it's ground up from small screens to large screens. How's this going to look? All the way up. And the rule of thumb is that's just it's what cool cats are doing nowadays. It's like just much easier because people keep bringing out these different sized tablets and these different sized TVs, and you just basically want to take into account where your audience are more specifically. So we've got 40% of our audience coming from mobile, so this is a big deal for us. We need to ramp up how good it looks on the mobile and how good it works on the mobile. But if your audience aren't coming from mobile, then and they're coming from TV, maybe you need to concentrate on the TV experience. So for instance, with all the new web browsers on TVs and interconnected TV stuff. So it's kind of it's just a rule of thumb. It's not actually like how everything should be done. And people have to disagree with it all the time, but it's generally good. How you launch is also quite important. Generally, you want to test the system in its production environment. So if it's going to break, don't tell anyone, put it up, see if it breaks, and then slowly make it better and tell people at those milestones. If you're making a new website, that's the best way to do it, because you can literally test it as you go. If you do what we did and tell everyone in one big bang, then everyone's going to rush to your website and it might go down, which it didn't for us, I don't think. But we had loads of hands on deck just in case it was going to happen. So try not to break your own website by telling the world's press about it the first day it goes up. And this is about relationships with your web designers. Make sure before you actually engage in finishing the project, you work out how the project's going to continue into the future, and arrange a service agreement or a retainer with someone, because it's likely that something's going to break at some point and it's going to need to be fixed. It's just the way it goes. So that's that. Pop quiz. What is... I've checked out. That's just too wonky. So HTML is...
Yeah.
HTTP is... yeah, pretty much. What is a CMS? RWD. Other than rewind. That's what's web design. Lamp stack. This is kind of more getting more obscure and harder as we go. Lamp stack. Anyone? Jokes.
Have you said like a meat packet?
I said like a meat
Packet. Close. It's Linux, Apache, MySQL, and PHP. So now you know. So if someone says, "Oh yeah, I usually use a lamp stack," you'll go, "Oh right, cool. It's Linux, Apache, MySQL, and PHP," and they'll go, "Whoa." SEO. Everyone should know what SEO is. What's SEO? Yeah. And why is that important?
Because you want your website. People get my
Yeah. API. This is one for you, Luke.
Semi-space.
What? Give up? I feel like this is only fun for me. Application programming interface. An SDK.
Software development.
Pardon?
Software development kit.
Yes. Software development kit. And last but not least, SaaS, which
Software as a service.
software as a service. There you go. So, what is SEO? Why is it?
On the previous list, API is something that I've just heard and seen and come across.
Don't you worry. Don't you worry. we won't get through this at this rate, but
Back on the stacks, is
Yeah.
it just the combination of languages that you use to build a product?
LAMP stack is just a reference to the technologies used to make a website.
So when people talk about an app stack,
Yeah,
it's the same, but it'll be a different collection
Yeah.
of languages.
yeah, just a collection of like what languages are you using to make that
Is it
product.
only languages, or does it also is there a sort of content management system sort of within the stack?
No, not usually. Because with this one, PHP could be any number of content management systems, or not,
Right.
as the case may be. Yeah, it's generally reference to languages, so that people can go, oh, instantly, I can do that, or why have you done that, or whatever. So, SEO. I'm hoping my team know all about this. No? Yeah. So these are some recent stuff. I could probably do a whole talk on SEO, but basically SEO is about how Google, Yahoo, whatever, looks at your website and puts it on the ranking of their searches. So when you search for Virgin Mobile, why is it that Virgin.com comes up top, for instance? That sort of thing. There used to be lots of horrible dealings. So if you talk to an SEO company, you really have to grill them about what exactly are they going to do, because a lot of the time they used to employ people to sit on forums and type about your products, right? Which is a waste of money and time. You want actual people to write about your products. And they are cracking down on that, and also automated versions of that. So they could send out little programs that will go to different forums and write in kind of broken English about your site or product and link back to it. And Google are getting better and better at discounting this sort of SEO tricks. So if you're dealing with SEO people, make sure they know what they're talking about, which they generally do, but a lot of the old practices are really bad and it costs a lot of money. So everything on your site has to be relevant. I mean, if your title of your page doesn't match up with the title of the URL, with the title of the content of what's actually contained in your content, then it just looks bad. So if on Virgin.com we have an article about Richard and the glass bottom plane, the title of the page on the bar here, like literally at the top, is going to be Richard and the April Fools of the glass bottom plane, and probably the heading of the page as well. And when the Google bots look at that, they go, cool, these things match up, right? And then inside the content of the text of the page, it looks through all that and goes, okay, there's references to Richard and glass bottom plane, and this all adds to the relevance of the page. So the more relevant your page is, and within your own site as well. So if you're running a site and it's all about how big data is changing the world, and there's loads of porn ads on it, it's a conflict of interest to the viewer, and therefore Google discounts it and puts you lower down on rankings. How Google actually works is mainly from following links from other people's websites, and every link to your website is like a thumbs up on Facebook. So like you like something, and if someone adds a link to your website, that's like a like for you. So what you're trying to do basically is make your website really relevant for its users, and the content's well structured, and to have loads of people linking to you. And the more people linking to you, the more like, cool, this website's like good and like, you know, makes sense for people or whatever.
Does that include Twitter and Facebook?
Pardon?
Does that include Twitter and Facebook?
Yeah,
Okay.
definitely. Because
Is
it's
it a discount for Twitter and Facebook?
no. It's less good than real websites because tweets are less static, let's say. But you still want as many links as possible.
Can Google search within Facebook streams?
No, but it knows that people come from Facebook.
Right, okay.
Yeah.
So if something goes viral on Facebook and you get lots of sharing, Google's
Yeah.
only going to count it if they actually click through and onto the site.
Yeah.
Okay.
One of the practices in web design at the moment is like app type experiences, where you don't load the page after the first load. So you get on the website and you click stuff and it just happens, right, all in the same page. You should never do that if you're building a content website, because the Googlebots can't really click on anything. They're just following links. So all that content, which is all on that page, is not available to that Googlebot, and thus you look like you have one page instead of 16. So don't hide your content. So if you've got really good stuff and loads of good people are going to comment it on stuff, then put it on its own page and people can link directly to that page and get more likes.
Is that related to Flash?
Yes, Flash is terrible for
Flash
SEO.
dead?
Yeah, Flash is mainly dead for most people because you make a website with Flash and Google can't see it. It's not strictly true, but you unless you're very, very clever, that's the case. Flash is great for making most videos still display in Flash unless it's on mobile, and lots of games are written in Flash. Whole websites, you should never write a whole website in Flash. It's terrible practice. Most adverts are Flash as well still. And yeah, look at your analytics, because looking at your analytics can tell you how people are searching on Google and arriving at you, and what they're coming for. So are they going via your homepage, or are they coming straight in on an article page? Are they coming mainly from Twitter? Are they other stuff? Are they only on mobile? That sort of thing. So that can tell you a lot about your website, and also informs your SEO strategy. Because if lots of people are searching for this one specific thing and land on one specific article, then maybe you want to write some more articles about that subject. Maybe. That sort of thing. Social media is important. There's more links. What's an API for? This is like the shortest API talk ever. So APIs are... That's it. APIs want specific access to your system. So you want your website to be locked down. You want it to be as secure as possible. But if you are Facebook, or you are us maybe in the future or whatever, and you want to give access to a specific part of your data, you basically write a set of functions that anyone can ask of the system. And that's what an API is. It's communicating with your application using this specific load of functions that you've said are okay to use. So when I'm calling Twitter, I might give it a security key, which I've got from Twitter, and I'm requesting all my tweets for Ben Byford, and it's going to go to this URL, which Twitter's given me as well. Click go, it goes to Twitter, it checks the authentication code against my code, and it goes, cool, and look up all Ben Byford stuff in my database, and instead of giving it to be like a website, it's giving it back to my application that requested it. So I can display those tweets within my website, for instance. So you can do that with loads of APIs all over the web. Most cool websites have them nowadays. So you could have just a website which just aggregates information from other people. Loads of websites do that. So that's what an API is.
Is that just some code that you would write into the site, or is this like something you bolt on?
No, it's code that you would write as part of your application. Yeah, but you can, if your application is quite modular, then you can just write it as a new extension of what you're doing.
And is that the logic that things like Flipboard and Feedly base themselves upon?
Yes, and also no, because they do a similar thing, but they go and request RSS feeds, which are publicly available anyway, so you don't need any security step. You just go and get the information. Okay. So RSS feeds are slightly different. It's like viewing a website but with no markup. What is an SDK for?
Sorry, can I just ask, what's the difference between an API and an iframe?
Iframe is a little snippet of HTML.
Okay.
And what does an iframe do?
I can't remember.
So,
it's in my head.
Yeah.
I'm like, why did I used to talk about it?
So API gets an information from someone else's database really and returns it, and then you can do what you will with that information. Whereas an iframe is a way of displaying a bit of someone else's website on your website, and you have no control over that, basically. So if I was to add an iframe into this presentation, I could, and display the Google prompt or whatever, but it would still be Google in that iframe. It's not on my site. It's just like a view into someone else's.
So when they update the Google icon every day,
it would change, yeah, because it's literally calling that website every time. There's nothing stored on my website. I have no interaction with their website. It's just a way of displaying. And that's good if you're displaying something like a email sign-up form, which you might get from MailChimp or something, and you might use an iframe for that. All the like buttons and tweet buttons, they're all iframes.
right?
Because they can just ad hocly change it, and it will change all the like buttons in the whole world, which is great for them, but really annoying for us because we have this shit like buttons, and you want to design them nice and stuff, but you can't. So an SDK is a software development kit, and it's actually really boring. It's just a load of software packages which allow you to generally code on a specific platform. For example, if you wanted to make a PlayStation 4 game, or an iPhone, or something on Android, Arduino, something like that, we have this development environment which could compile down for that specific device, because these devices aren't as generalized as computers are, basically. So they can't do all the stuff that computers can do necessarily, because they're geared up for this other thing. So they give you access to the software to make it easier for you. Yeah. Cool.
And if you say I wanted to go and write on a phone app,
Mm-hmm.
is that a different set of languages that I have to learn, and it's all sort of baked into the SDK?
Yeah. Well, it is a specific set of languages, but it's not necessarily specific to that platform. It just gives you the way of compiling it for that platform. And it gives you loads of helpers. So if you were writing a iPhone game, you want to see if someone's touched it, but that language won't inherently tell you if someone's touched it, so it gives you functions to allow you to hook on to these things. So if you were writing outside the SDK, you wouldn't know what those functions were. You would just be calling something that didn't exist. So it's kind of like to help you along with the things that you don't know about. Yeah, because only the phone does that, or knows that it's been moved around, for example. So there's all these extra stuff which is hardware specific, generally. This would be a question for Hannah if she was here. Chat. This is really subjective and like just me telling you the answer to this. Why is Facebook and Twitter still the king of social media?
Because more people use them and get more engagement than any other platforms.
Wrong. That is merely what they do, right? Mm-hmm. That's like they encourage people to use their platforms. But how is it that they haven't died and someone else hasn't done something similar? Again, this is purely subjective. In my opinion,
first to market thing.
No.
First to scale to market.
No. Ever heard of MySpace? Friendster? FriendFeed? All the other ones? Bebo? Yeah, nothing to do with first to market at all, actually. In my opinion, it's because they integrate with everything. So one of the cleverest things I think they've done, both platforms, is you can sign in to other websites using them. You can use other applications using them. They basically said, we're going to make ourselves integral to how the internet works, which is genius. And that's why people still use them over the next guy. Because it's just everywhere, right? Yeah, so I could talk about that for ages. But that's what I think is the most technically clever thing that Facebook and Twitter have done. Because you can make Twitter apps, which like aggregate stories about Twitter in tsunamis and stuff like that. They give you access to their information, and they give you access to it not necessarily on their platforms. So,
how many social networks do you use in a given day? Which ones are there? Are there any aside from Facebook and
I probably use Vine quite a lot at the moment,
Twitter.
and Instagram. That's about it.
There's just so much hype about both of those guys going public and how sustainable it is.
Yeah,
Well, who's the Facebook killer going to be?
yeah. But I don't think there's going to be a Facebook killer. I really don't think there is, because unless they really mess it up, they're integral to the web. That's what they've done now. So if there is no Facebook, loads of stuff doesn't work. Like loads of people's websites will not function. So I don't think it's useful to look for the next Facebook killer or social network, because social networks for me are dead. Basically, because we've done it, we've solved it. Like it can only get bigger from here until everyone decides that social networks aren't actually good. Or maybe they will. I don't know. Yeah, so I think that deserves its own workshop to tell you all about like more interesting fun facts about social media. But I'm not the person to tell you about it, unfortunately. So 3D printing and where is the Internet of Things? Yeah. So 3D printing is cool, right? What do people think 3D printing is?
It's localized manufacturing.
Yes. That's kind of exactly what I wanted to hear, actually. What would I not have wanted to hear? No, it's not making things. It's the fucking Bible, right? This is what they're selling to us. 3D printing is the next industrial revolution. Effectively, it's the Gutenberg. That's what people want you to believe. That's what people are saying about it. It's phenomenally liberating. And this is kind of what they look like. So it's about bringing power into people's hands. What Gutenberg did was made reading and religion accessible to every man. And this effectively is being hailed as the Gutenberg of our generation, where people can make anything effectively with one of these machines in their own house, and manufacturing is dead. There's lots of arguments about that, but that's the kind of thing that people are going for.
Rolls-Royce just announced that they're using this for their turbines now.
For the turbines? That's cool. So the beauty of this is actually it's very simple technology. It's a printer with a y-axis. That's it. I mean, it doesn't get simpler than that. The head goes up and down, and it moves left and right, and that's all it is really. It just so happens that different ones enable you to print different types of materials, and I imagine that in 10 years' time we'll probably have one which prints lots of different materials all at the same time and is much bigger or smaller, whatever, than it is today. We do things like this, which is cool. Someone was telling me earlier that someone's printing a prosthetic face for someone's face that concaved in. So you can make prosthetics with them, with organic material. You can make buildings with them. There was an article in Wired maybe a couple of years ago which was about building a 3D printer which they were going to send to the moon and make moon bases, and then in 5 years' time they could go up there and there'll be like a whole moon base and it's going to be amazing. I don't think they've ever talked about that since, but hey, I think it's quite a nice idea. They can make prosthetics. So there was just this week a story about this little kid's dad, and he had a kind of a misshapen hand, so he had very, very small wrists and fingers, and he made this for his son so that he could better integrate at school and pick up pens and bags and all sorts of stuff. But the beauty of this is every time he grew, he could make a new one which was bigger. And he didn't need any real skill or know-how to be able to make this and put it together himself at home on a very limited budget, which is pretty phenomenal. That was I kind of shot through 3D printing because I didn't really have much time this morning, but and I'm going to do the same for big data and the Internet of Things, connecting the real world with data. So I don't know if anyone was like interested in the hype about the Internet of Things about 5 years ago, that your fridge would be connected to your supermarket and your phone would be able to tell you that you were running too fast, or that people would be able to follow you around and your house would know that you'd come home and it would make you a coffee or whatever. So all these things are still possible, but it's about commercialization of these products and proprietary systems. A lot of these things don't talk to one another because people want to be in control of that information. So whether it's you personally or whether it's large companies. So a large company maybe will be providing you a product, but maybe you don't want to integrate with that product because you know that that data is going to their servers or something like that. And they might be doing something weird with that information. We are being tracked every day with our phones, and the big data bit of this is what the hell do you do with all that information? The amount of people that has phones or have internet connected devices is ridiculous, and that amount of information is almost not worth keeping. It's almost not worth handling because it takes so much computation and actual effort to discern anything from it. So there's lots of companies at the moment popping up trying to get into that space, trying to make sense of all this information, whether it's different people telling you what the transport in London is like today instead of TfL, whether it's the air pollution from different parts of the world aggregated to inform health decisions, or whether it's your phone telling you like you need to go jogging more often or whatever it is, or recording medical information about you. I think these are all kind of interesting and just things to be doing, but they don't all communicate with each other at the moment, and it's a huge data set to actually deal with. So that's why we don't necessarily live in the Internet of Things today. Kind of.
What about personal data and wearable tech? So to the other end of that scale, where you have all this information about yourself and you use it as you want to, if you want to aggregate it with a group of people that you're choosing.
Yeah, I mean, it depends. It's kind of it's just almost too specific still, isn't it? It's kind of like, well, my phone might not chat to my shoes, and my shoes might not chat to my hat, and my hat might not. So you kind of need the system to all work harmoniously together, and for that information to be good for someone. So if I'm using my Nike band, it's not necessarily going to make sense for my coffee machine or my fridge. It might do, but I don't know if they talk together. And if you're keeping that information, are you a programmer and able to do anything with that information, or a data analyst maybe? So it just doesn't all match up in my mind yet. There are amazing things happening in countries like Brazil, where they have a very, very Internet of Things integrated city over there. I can't remember exactly where it was, but the mayor had basically like a big central computer station where he'd just watch the whole city unfold, and you have things about pollution, you have things about the trains, and you have things about what people are saying about the environment, what people are saying about their work life, and all these things aggregated so they can make informed decisions about where to place their police, where to place their rubbish collectors at any one time. If this road's going to be shut, they can move things around, and it's for kind of city building and mayors and that sort of thing. That information is amazing, but for us, I don't think anyone's cracked it yet, and I don't think anyone has a really good idea that I've seen to make the stuff all work together, where you're not worried about privacy or this and that and the other, or being looked at by the FSA or snooped on, and they just accidentally, algorithmically think you're a bomber because you went to buy some paraffin or something like that. That's I think actually the crux of the worry for me about all this sort of stuff. It's like, where there's the line between computers and the human interaction. If people are tracking your face as you go through the stations, what does that mean? What are they going to do with that information?
Does anyone actually know what that interface between big data and people actually is and looks like, and how it works? Or is this, all the stuff that's going on with the NSA, it feels like sort of people in suits behind sunglasses,
Yeah.
no one really knows who they are or what.
Yeah, no one. Well, I think the major problem is like they probably don't know what they're doing with the information. You're probably just like, at some point we'll probably need this, won't we? And at the moment they're going, just like, ooh, sorry, like we don't actually have any idea what to do with all this stuff. Like there's tons of it. Look at it. I imagine that's what they're doing. I imagine they've probably got some really clever people doing something, but how useful it is, I just literally don't know. I mean, I don't want to accidentally end up in prison because literally I bought some paraffin for my fire juggling equipment. I don't want to have been told off for unlocking my iPhone, or all these things that potentially could crop up. I mean, when does the line between threat and normal everyday life or bohemian life or whatever it is lie? And I think that's worth arguing over. Whether we're being tracked or not, we're always going to be tracked. Like whether it's the FSA or whether it's programmers or whether it's someone else. I think it's the commercial thing about being tracked. It's like Google track us, Apple track us, all these things happening because they can aggregate that data into marketing materials, like market to specific people, adverts and such like. Google are exceptionally good at that. So I don't think it's even worth talking about whether we should be tracked or not, because there's not much we can do about that unless we shut the internet down, destroy the DNS servers. But whether we get told off for what we do in our own lives because of that information, that's probably a moralistic argument that we need to have, basically. Yeah. And these men in suits don't know what they're talking about. That's my
Do you
opinion.
think that's quite a common problem, whether it's intelligence or financial markets or controlling nuclear reactors in southern Iraq with viruses, that these systems are kind of collectively more complex than anyone working on each individual bit kind of realises?
Yeah, it's
Anyone
more.
can hack into a nuclear power plant. They're all on separate systems, right?
No, they have. That's the
That's
problem.
Stuxnet virus.
Yeah, Stuxnet.
Yeah, isolated the centrifuges of the Iran nuclear reactor through a big, complex international connection of different systems and platforms.
Yeah, so that's the end of my presentation. So we're happy to carry on talking about stuff now if you want, but that's all I had prepared. If you wanted to know what this was reveal.js, which if you're interested in learning HTML, you can use. So thanks for your time, those who are still here, and
Thank you.
Thanks, Jay.